Hello students, how are you doing? Today we'll be dealing with chapter 6.3, the principle of conservation of energy. Welcome to class. Principle of conservation of energy. Let's start by dragging the words into the correct boxes. The principle of conservation of energy states that the total amount of energy, all right, before and after the conversion is constant. Energy cannot be created nor destroyed, but the total amount of energy conserved is constant. So let's check. That's correct. Let's move on. Energy efficiency. Let's define energy efficiency by dragging the words into the correct boxes. Energy that we know, all right, is expensive. Using more energy than necessary damages the what? What do you think that will be? Environment. Most waste energy ends up as heat energy. All right? And sound energy. When fuels are burnt, heat is produced, okay, as an intermediate step. Friction also generates heat, which is reduced through, what do you think we can use to reduce friction? Lubrication and streamlining. Wasted energy is referred to as what? Low grade energy. So let's check. That is all correct. Fantastic. So we move on. How do we make better use of energy? The efficiency of an energy conversion is the fraction of the energy that ends up in the desired form. Looking at a filament lamp and an energy efficient lamp, each of the two bulbs produces the same amount of light energy every second. However, because less energy is emitted as heat, the energy efficient lamp requires a much smaller input of electrical energy. This is illustrated in the diagram below. We are trying to give a comparison between a filament lamp and an energy efficient lamp. How well they conserve energy and how well they waste energy. For a filament lamp, electrical energy is 100 joules. Now, the wasted or thermal or heat energy that is produced is 85 joules, while the main light energy is 15 joules. But for an energy efficient lamp, electrical energy is just 25 joules. The waste thermal or heat energy that is dissipated is 10 joules, while light energy in itself that we can see from the what? Energy efficient lamp is 15 joules. So this particular table shows the typical efficiencies for some important devices. That is, when you are talking about efficiency, we are trying to talk about the rate of work output to that of what? Work input for each of the device. Now, for electric heater, its efficiency is 100%. That means work output and work input is equal. For a large electric motor, we have 90%. For washing machine motor, we have 70%. For a gas-fired power station, we have 50%. For a diesel engine, we have 40%. For a car petrol engine, normal cars that we see on the road, their efficiency is 30%. I meant the engine. And for a steam locomotive, the efficiency is 10%. So let's deal with this true or false question. The most common forms of wasted energy are thermal energy and sun energy. This is what we discussed earlier from one of the points I raised as we started this class. So the answer was true. So we can check now. That's right, correct. Now, let's move on to the next slide. Energy becoming dissipated. Energy changes are usually less than 100% efficient. Energy escapes and wasted as heat. Energy changes makes objects and their surroundings warmer, and it is difficult to get such energy back. Energy dissipated always ends up as heat in a medium. For example, the dissipation of a cell inserted into torch, which gives energy as light, which is absorbed by the surface, is photon. The rest energy is then converted to heat. How then do we calculate efficiency? The percentage efficiency of an energy change can be calculated as follows. Efficiency is equivalent to useful energy output divided by energy input multiplied by 100%. I repeat, efficiency is equal to useful energy output divided by energy input multiplied by 100%. Do not forget. So let's move on to the next slide. Now we have to calculate this particular question. So let's do it. A filament lamp is supplied with 100 joules of energy, electrical energy. In that sense, it produces 15 joules of useful light energy. Its efficiency is, don't forget I told you that efficiency is rated in what? Percentage. That is what? Energy output divided by what? Energy input multiplied by 100 over 1. Then you put your percentage there. So with this, we have 15 joules, all divided by 100 joules, multiplied by what? 100%. Joules, we cancel joules, 100, cancel 100. So we can there have 15%. Do we have it as part of our option? Let's pick it and check. That is correct. Now, let's choose the correct statement before we call it a day. Now, number one, the efficiency of an energy conversion is the fraction of the energy that ends up in the desired form. That is just what we saw from the last slide before we moved on to this. When we dealt with energy output divided by energy input, that is the ratio of energy output to energy input, will give us the what? That fraction of the energy that ends up in the desired form. Number two, the efficiency of an energy ratio is the fraction of the energy that ends up in the desired form. The statement is false because of the word ratio. The efficiency of an energy conversion is the multiple of the energy that ends up in the desired form. That statement is what? False. So the correct statement here is that the energy of an energy conversion is the fraction of the energy that ends up in the desired form. That is it. Correct. We've come to the end of the class today. Do well to check our website www.edubbey.com. Subscribe, and subscribe for more of our interactive courses and notes, and also our interactive videos. We'll be willing to help at any point in time. Do have a great time. Bye.